In this example, 9.1, we're told that a sinusoidal current has a maximum amplitude of 20 amps, and that the current passes through one complete cycle in 1 millisecond. The magnitude of the current at t equals 0 is equal to 10 amps. And it's broken up into several parts. Part A asks us to find, or asks what is the frequency of the current in hertz, or cycles per second. Now, from the problem description, we know that the current passes through one complete cycle in 1 millisecond. So we know that t, our capital T, the period, is just equal to 1 times 10 to the negative third seconds. And from the previous lecture, we know that our value for frequency in hertz, cycles per second, is just equal to 1 over the period, the reciprocal of the period. So we just plug and chug. So we'll say that F is equal to 1 over 1 times 10 to the negative third seconds. And if you plug that into your calculator, or just sort of reason it out in your mind there, you'll get that the frequency is equal to 1 times 10 to the positive third hertz. You can also say that's equal to 1,000 hertz. It's also equal to 1 kilohertz. So there we go. We knew what the period was. We knew our equation for frequency in hertz. We plugged it in and we got our answer, 1,000 hertz. Part B asks us, what is the frequency in radians per second? Radians per second. So from the lecture, we have an equation for this as well. We know that radians per second, little omega, is just equal to 2 pi times the frequency in cycles per second times f. So we plug those values in there. So we'll say that omega is equal to 2 pi times 1,000 hertz. So that gives us a final answer there. Omega is simply equal to 2,000 pi radians per second. Nothing to it. All right, part C, probably the most interesting part of this example, says, what is the mathematical expression for current? Mathematical expression for the current. So let's start with our equation from the previous video. We know that I will be a function of t, will be equal to I sub m times the cosine of omega t plus phi, and that'll be given in amps. So let's plug in what we know already. We know that we want IT. We know that our maximum amplitude of current here is 20 amps, so it's going to be 20 times the cosine of omega t, so we found out that that's 2,000 pi times t plus phi amps. But what is phi? What is our phase angle? We talked about in the previous video that phase angle just tells us what our value of that sinusoid will be at t equals 0. And in the problem description here, it says the magnitude of the current at t equals 0 is equal to 10 amps. So what we can do is we can say that I of 0 is equal to 10 amps. And we'll say that's equal to 20 times the cosine of 2,000 pi times 0 plus phi amps. Do a little bit of algebra. 10 amps is equal to 20 times the cosine of phi amps. And so we'll say that phi is going to be equal to what? The inverse cosine of 10 amps over 20 amps. Now, if you punch that in your calculator, and if you remember from the previous video, for some weird reason, we're going to, by convention, keep phi, our phase angle, given in degrees. So the inverse cosine of what is effectively 1/2 is just equal to 60 degrees. So we're ready to go ahead and punch that into our expression. So finally, we've got that I of t is equal to 20 times the cosine of 2000 pi t plus 60 degrees given in amps. Finally, part D wants us to calculate the RMS value of the current. So let's say, what is the RMS value? And from the previous video, we remember that our I sub RMS is just equal to our maximum amplitude divided by the square root of 2. Let's plug in the values that we've got. I RMS is equal to 20 amps over the square root of 2. And if you put that into your calculator, you're going to get that our IRMS is just equal to 14.14 amps. And there we go. That is it for this example. Just to recap, we were told that we had a sinusoidal current with a maximum amplitude of 20 amps, that it passed through one complete cycle in 1 millisecond, and that the value of the current, or the magnitude of the current at t equals 0 was 10 amps. We calculated the frequency from the period, 1 millisecond. Then we calculated the frequency in radians per second by multiplying that by 2 pi. Then we derived our mathematical expression for the current using this basic formula. We already had some values, but we had to solve for phi, the phase angle, which we know is the value of our current at t equals 0. Found that to be 60 degrees, plugged it in to get our general expression. And then finally, we used the maximum amplitude to calculate the RMS value. So if you have any questions or comments, please let me know. And if not, I'll see you guys in the next video, which will be another example.